Today I'm going to show you yet another reason why I keep telling you as soon as you see a linear equation to begin by solving for y. Remember, the rectangular coordinate system began with the x-axis, had 0, the positive numbers, and the negative numbers to the left. Now that's the x-axis. The y-axis, of course, went vertically, with the positive numbers going up and the negative numbers going down. Okay? Now let's look at this line. The line representing the equation y equals 2x minus 1. That's it. You're going to have to trust me. That point right there is where it's intersecting the y-axis, isn't it? Well, that point is called its y-intercept. It's just what it is. It's where it intersects the y-axis. Let's look at another. This equation, y equals minus 3x plus 4, while it's solved for y, if I graphed it, would be right here. Now, where is it intersecting the y-axis? Its y-intercept is 4, because that's where it intersects the y-axis. You might want to note that its x-intercept is 1.5. But for right now, we're only talking about the y-intercept. Now let's go back to this line. We know the y-intercept is minus 1. I want you to note something. What is the value of x at the y-intercept? In other words, where are you on the x line? Well, it's right in the middle, isn't it? It's 0. And if you put 0 into this equation for x, of course the part of it will cancel out and you'll get the constant, y equals minus 1. Well, that was the y-intercept, wasn't it? The point 0 minus 1. We're going to have a pattern here. If we go back to the second equation and put in 0 for x, what are we going to be left with? The constant. So you could say, if you'd solve for y, that the number, the constant sitting by itself in that equation, will always be the y-intercept. The other number, the number in front of x, will always be the slope. You don't have to go to any trouble. If you've solved for y, you don't have to go to any trouble of subtracting and dividing and all that. If you'll solve for y, that number is always the slope. So in summary, if we solve an equation for y, it is in what's called slope-intercept form. It makes sense, doesn't it? Where the number in front of x is always the slope, and the other number is always the y-intercept. For instance, in this equation, now that I've solved for y, the slope is 7, and the y-intercept is 3. Just that easy. In this equation, the y-intercept is 7, and the slope is minus 2. Now note, I said the number in front of x is the slope, not the first number, the number in front of x. So if I switch it, negative 2 is still the y-intercept, and 6 is still the slope, the number in front of x. How about this one? Well, it'll still work. 7 is the slope. What's the y-intercept? Well, what's the number sitting by itself, the constant? You could have written plus 0. Okay, so you kind of have to imagine that, and the y-intercept will be 0. In this one, you kind of have to imagine a number in front of x. We know the number sitting by itself is the y-intercept. What would the slope be, the number in front of x? You could write it like this, couldn't you? And the slope is 0. And if you think about it, y equals 3, the graph does have a slope of 0. Y equals 3. It's a flat line, isn't it? How about the slope and y-intercept of this equation? Remember, you can't do anything until you've solved for y. Now, who's keeping y from being by himself? The 6x, so I'll subtract 6x from both sides, which I really can't do on the right. I just write 8 minus 6x. Don't be telling me 2 something or something. And on the left side, I still have to get rid of that 2 that's multiplying the y, so I'll divide both sides, everybody on both sides, and I'll get y equals 4 minus 3x. Now it's easy. The slope is the number in front of x minus 3, and the y-intercept is the other number, 4. Got it? Well, let's work backwards. I want you to give me the equation this time. Give me the equation of a line with slope 5 and y-intercept minus 3. Remember, it's always going to be of this form, where the slope is the number in front of x and the y-intercept is the number sitting by itself, the constant. So, there's your answer. Y equals 5x minus 3. It's very easy if you know the form. Even if I said, give me the equation of slope and y he, you're going to need to know this. The equation will be y equals x plus just fill them in. Get the idea? How about finding the equation of a line with slope 2 that contains the point 1, 5? Well, right away I'd take the 2 and put him in for the slope, but I still have to find the b. But I do have added information here. I have a point that fits. What I can do is make it fit. Remember, the first number is the x and the second number is the y. So let's put the 1 in for the x and the 5 in for the y and make it fit. Well, if 5 equals 2 times 1 plus b, or 2 plus b, what does b have to be? Subtracting 2 from both sides, b will have to be 3. Now that's not the answer. The answer is the equation. So I take what I know to be the slope, which is 2, and what I know to be the b, or y-intercept, which is 3, and I get the equation. Now, wait a minute. Why would we even want the equation? Because once you have the equation, you can find other points of this function if you would. You can find all kinds of points once you have that general equation, and that's what we'll use it for. This may be the equation for converting amongst temperatures, or the equation for predicting stock prices, or once you have that equation, you can use it. Let's try it again. Make sure you can follow it. I'm going to get the equation of a line with the following clues. A slope of -3, and it contains the point -2, 8. Well, this got negatives coming all out of the place. I'm going to use my general equation, put in the slope that they give me, and now I've got to make that b fit. Well, let's put in the first coordinate for x and the second coordinate for y. Let's see, -3 times -2 is 6, so I'll solve for b. Probably do it in your head. And b is going to have to be 2. But remember, they asked for the equation. So there's your answer.
You are correct, sir. Wait a minute, 99. That gives me an idea.
We could use this to graph lines. I'm going to graph a line containing the y-intercept of 2 and a slope of -1 over 2. Well, if it has a y-intercept of 2, that's the equation, and that's the y-intercept, because it hits the y-axis at 2. And remember what the slope means. Between any 2 points, I'm going to execute the slope of going down 1 and over 2 and find another point. So really, if I had the equation, I could draw the line just that quick. How cool is that? That's going to be very useful. Let's try it again. Let's draw the graph of a line that has a y-intercept of 1 and a slope of 3. Well, right away we can come up with the equation. y-intercept of 1 and a slope of 3. The 3's in front of the x and the 1's the constant. Well, I can put the y-intercept. What does it mean to be the y-intercept? It means it hits the y-axis at 1. So the point 0, 1 is on this line. The other thing is that the slope is 3. Now 3 as a fraction is 3 over 1, isn't it? So up 3 and over 1, and we'll have another point. And once we have 2 points, you're there. Now you could go up 3 and over 1 from the next point also, but you'd still be on that line. So you've got the line and the equation to boot. Let's try and do 2 at a time. If you consider drawing 2 lines at a time, 3 things can happen. One is that they could look like this and be what we call parallel, never meet. Or they could intersect, right? These 2 lines intersect. What's the other third possibility? Guess you won't guess it. Is that the 2 lines are actually the same line. That could happen too, but doesn't happen very often. So those are the 3 possibilities. Parallel means no points in common. Intersect means 1 point in common. And same line, of course, as you can see, have infinite number of points in common.
Let's play. Here we go.
Now I'm going to have to ask you, given the equations, which of the 3 is going on here? And you should be able to tell me, actually, without drawing the picture. Well, we know we can't do anything until we solve for y. Let's solve the first one for y, subtracting 6x, and we've done this one before, and divide everybody by 2. And there's that one solved for y. And this one, divide everybody by 4, and we have y equals 4 minus 3x versus y equals 2 minus 3x. Well, we're not going to even draw the picture. I know that the slopes are the same. Think about 2 lines that are leaning the same way. They have the same slope, but they're different slope. Now, they're different lines because the y-intercepts are different. 2 lines that have the same slope but different y-intercepts. I didn't even have to draw them. I know they're parallel. That's what it means to be the same slope. Let's try some more. This line and this line. Well, we can't do anything until we solve for y. So let's subtract 6x and divide by 2. You get pretty good at this after a while. And let's take a look at this one. We're going to subtract 12x, and I guess I'll have to divide everybody by 4. And this might stare you right in the face. The slopes are the same and the y-intercepts are the same. You might not have guessed it, but those lines really are the same line. You couldn't tell anything until you solved for y, could you? Do one more. Let's solve the first one for y. Can't do anything until you've solved for y. Who's keeping y from being alone here is the 2, and that's all. He's the only troublemaker. Dividing by 2, I get y equals 3x plus 4. Subtracting here and dividing, I get y equals 2 minus 5x over 2. Now that looks difficult, but if you think about it, all that matters is that the slopes are different. As soon as the slopes are different, 2 lines that have different slopes, considering the lines go on forever, they have to touch. They may touch in heaven or hell, but they have to touch. And if they touch, they intersect. They intersect in 1 point. So the point of this is you can do this, you can analyze these problems without even drawing a picture. So you need to practice that. Let's go do the homework.